Hi Bhargav.
Hi.
So let's have a quick introduction. Let me introduce myself first. My name is Vikram Rawat, and by education, I'm a mechanical engineer. But I've been in the field of education for the past 7.5 years now, almost about to be 8 years. Uh, and I train people for Olympiads. I teach Vedic mathematics, and I also help people prepare for various other competitive exams. So that's my introduction, Bhargav. What about you?
Mm, I'm 10 years old. I like all the outdoor games. I play all the outdoor games.
Okay.
I study in Naval Children's School, NCS Mumbai. As now, I may get transfer next year.
Okay, that's great. Okay, Pooja ma'am, shall we start with the demo?
Yes, Vikram, you can continue with the teaching part and we can end the demo by 7 p.m. Okay?
Okay, sure. Thank you. Okay, Bhargav, before we start, let me just quickly share a PPT with you. Just give me a minute. Okay, Bhargav, just give me a minute. There's somebody else who has joined the class.
Welcome, Kal Lastya.
Hi Kalthuri, am I audible? Kalthuri, could you please switch on your camera?
Vikram sir, I think we can continue.
Okay.
We can- yeah.
Bhargav, please turn on your camera. Okay. Kalturi, can you hear me?
Yes, sir, I can hear it.
Okay. Kalturi, we just had an introduction, and so I'll just quickly introduce myself again. My name is Vikram Rawat, and uh, by education, I'm a mechanical engineer. I've been in the field of education for the past 7 years now, and we are going to discuss a few topics of mathematics since you have joined for the Maths Olympiad classes. Let's try to understand what these topics are and see, a general problem with mathematics or people who face problems in mathematics is we try to memorize the steps of solving the questions and only that. But here we'll try to change our approach. Our approach would be to understand things, and these steps should be a result of understanding. It should not be the first thing that comes to our mind. Like whenever you look at a question, the first thing that comes to your mind is understanding the logic rather than what was the first step of solving this question, what was the second one. So this will automatically come to you if you understand the topics. Let's look at the example of the topic fraction. Do you people know what fractions are?
Yes.
Can anybody explain what are fractions?
Fractions is when a whole is divided into equal parts.
Okay. When a whole is divided into equal smaller parts is called a fraction,
Yeah.
right? Okay. Okay, now before coming into different types of fractions, there are two important terms related to fraction. One is numerator, the other one is denominator. Numerator is the one
On the top and the
on the
denominator
top,
is on the bottom.
and the below is called denominator, right? This is the numerator, and the bottom one is the denominator. Okay, now do you know what are the types of fractions?
Yes.
Can you tell me?
Like, unlike, mixed, proper,
Okay,
improper, unit.
okay, there are like, there are unlike, proper, improper. Let's start with proper and improper fractions. So we know proper fractions are when the numerator is smaller than the denominator, and improper is when the denominator is smaller than the numerator. I'll give you an example. Let's say a fraction like 2 by 5, where the numerator is the smaller one, is a proper fraction. Whereas a fraction like 5 by 3, where the numerator is greater than the denominator, it's called improper fraction. Let's also understand why do we call it improper? What's so improper about it? Yes, Bhargav.
It's improper because 5 by 3, we can't take 5 things out of 3 things.
Okay. Okay. Uh, very close to the actual explanation, but not exactly correct. Let me explain what happens. So first of all, when people started talking about fraction, it goes thousands of years back. So it was considered that fraction is always the smaller part of a whole. That means when you divide one whole thing into smaller parts, you're talking about the smaller part of the whole, right? This one thing would be a fraction of like 1, 2, 3, 4, 5, 6. So 1 by 6. And when we had these fractions where the numerator was greater, it became confusing. How can something be more than the parts? Like if there are only 3 parts, how can we talk about 5 things out of these 3 parts? So that is why this term improper came into existence. There is nothing improper about it. It's simply that earlier it was thought that the fraction will always be smaller than the whole. That means how many parts you make of it, the numerator has to be smaller than the total number of parts. But in this case, what's happening is it's actually, if you look at it, 3 ones are 3 and remainder 2. So it is one whole and a 2/3, isn't it? When we talk about 5 by 3, it's one whole, that means one complete thing, and another, this is one whole, make 3 parts of the next thing, and 2 out of these 3 parts. That's 5 by 3, right? It's simply because of our understanding that we did not understand what these improper fractions were. They called it improper. And mixed fraction is this form of improper fraction. That means when you convert an improper fraction into a whole and a fraction. Do you people know how to convert an improper fraction into a mixed fraction? Kalturi?
Yes,
Do you know how to convert improper fraction into mixed fraction?
sir, I know how to convert mixed numeral into improper.
Sorry, what?
I know how to convert mixed numeral into improper.
Okay, you know how to convert mixed fraction into improper, but not how to convert improper into mixed.
Yes, sir.
Okay, let's discuss that only then. Let's say we'll take a new fraction now. Let's say you have a fraction 7 by 3. Now you have to convert it into a mixed fraction. So what you'll do is you'll divide 7 by 3. What is the quotient that you get? Okay, let's do the division. 7, 3. 3 twos are 6. Subtract and you get 1 as the remainder, right? Is that clear? Kalturi, this is specially for you, huh? Okay, so you write the quotient first. That means, see, you can also understand the logic behind it. The 7 is being completely divided by 3 twice, 2 times. Isn't it? That is why 2 whole and then a fraction. After dividing by 3, you get a 2 whole, and what is the remainder? What remains
One.
after the division? 1. 1 out of what?
1 out of 2? No, 1 out of 3.
Exactly. That's the mixed fraction. So it's 2 whole, 1 by 3. Does it make sense?
Yes.
Easy to understand?
Yes, sir.
Okay, let's see. So you give it a try now. Let's take 12 by 5 and convert it into a mixed fraction.
12 by
12 by 5. You have to send the answers in chat, huh? Don't you have a pen and a paper, Kalturi?
Sir?
Don't you have a pen and a paper?
No.
You're doing it mentally?
Is my answer correct?
Let me check. Good. Yes, it is. It's correct. We'll just wait for a minute. Let Kalturi also finish this, and then we'll move to the next topic.
So fetch a pen and paper and come.
Sorry, what, Bhargav?
I'll also go bring a pen and paper and come.
Sure, sure.
Sir, is this the correct answer?
But I can't see what's there. Can you read it out for me?
Sir, it's 2 by 5.
2 whole 2 by 5. Okay. That's how you read it. 2 whole and then the fraction.
Okay.
Okay. It's correct. Absolutely correct. Let's understand. So what you've done is you've divided 12 by 5, and 5 divides 12 twice completely. 5 twos are 10, and then you get a remainder of 2. So how many whole 5s? 2 whole. Right? So this is basically dividing into 12 parts and making groups of 5. Dividing something into 12 parts and making groups of 5. So you will be able to total 2 such groups, and then there will be a smaller fraction, which will be the remainder. That is 2 by 5. Is that clear? Okay, great. Do you want to try one more? Or should we move to the next topic?
Sir, can we try one more?
Sure, let's do one more. Okay, convert 10 by 7 into a mixed fraction.
Sir, is 1 whole 3 by 7 the answer?
1 whole 3 by 7 is the correct answer. Great. Great. Okay. So the next thing we'll try to do in the classes would be to do this mentally. Like you simply divide 10 by 7. 7 ones are 7. right? You know what the quotient is. You write the quotient first, and then when you divide it by 7, the remainder is 3. You write the remainder, and the numerator remains as it is.
Sir, I do it mentally only.
Great. Is this clear, Kalturi?
Yes, sir.
Okay.
Sir, and my name is Lasya, not Kalturi.
What's Kalturi then?
Sir, it's my surname.
Okay, it's Lasya Kalturi.
Sir, no, sir, only Lasya.
Okay. Okay, next, a very interesting concept of equivalent fractions. What are equivalent fractions?
Sir, equivalent fractions are fractions that have a different numerator and a denominator, but the value is the same.
Okay, let's understand. Equivalent, it sounds like equal, right? It looks like this term has been derived from the word equal, and that's what it means. Equal fractions are equivalent fractions. They just appear different but are equal. That means have the same value. I'll give you an example. Let's say, okay, the example is right here. One third. One third of something is, let's say, if you divide this one whole into three pieces, so this one part of this whole thing is one third. Similarly, 2/6. If you look at 2/6, it's simply multiplying both numerator and denominator by 2. 2 ones are 2 and 3 twos are 6.
We
So
can
2 by
divide or
6,
multiply the numerator and denominator with the same number to get the answer, right?
exactly. Lasya, did you get it?
Yes,
What
sir.
it means? Okay, you can keep on making equivalent fractions. All you have to do is take 1 by 3, multiply new numbers, but it has to be the same number for both numerator as well as the denominator. If let's say the number is 3, it would get you 3 and 3 threes are 9. Let's say if it is 10, so it would get you 10
10
by
by
30.
30.
So all of these fractions, although look different, 1 by 3, 2 by 6, 3 by 9, 4 by 12, and 10 by 30. All of them look different but are equal, are the same fraction. How do you know that? You can simply cross check. Like if you simplify 2 by 6, you will find that there is a common factor for both 2 and 6, which is 2. You can divide both the numbers with 2. And if you divide both the numbers with 2, you'll get 1 and 3 twos are 6. 1 by 3. You'll get the same fraction. Is that clear? Can you
Yes.
tell me some equivalent fractions for 2 by 5?
It would be 4 by 10
Okay.
and
Let's do one thing. Let's write it in the chat. Just give me 3 examples of equivalent fractions for 2 by 5.
I sent in the chat.
Okay, let me check. Okay, it's all correct.
Sir, I'm not able to chart here.
Okay, look at the blue button in chat.
Also,
There you'll find an option for new chat. You'll get a list of people.
Yes, sir.
Select my name and you can start a chat. It will open a new chat box.
Mm.
Done, Lasya?
Sir, 1 minute.
Sir,
Sir, done.
Okay.
sir, I'm gonna send you some more 3 answers. Are these also correct?
Sure. Send it to me. Okay. All of them are correct. Very good. Bhargav. Okay. That was a neat trick. So the new answers Bhargav has sent is 20 by 50. Simple multiplication, 200 by 500. 2000 by 5000, which are all right and easy to do. Okay, great. So if you've understood what equivalent fractions are, let's also talk about like and unlike fractions. We'll quickly talk about like and unlike fractions. So like fractions are those which have same denominator. If the denominator is same for two fractions, two or more fractions, we call them like fractions. Unlike fractions are, now again, it might sound like fractions are exactly the same. They look alike, but that's not true. Only the denominator is same. Unlike fractions are the fractions where denominator is different. That's the only difference. Let's see if we have examples of this. Okay, no. Let me write it for you. So for example, like fraction would be 3 by 4 and 1 by 4. The numerators are same, so these are like fractions. Unlike fractions, 1 by 3, 3 by 4. Denominators are different, that is why unlike fractions. Another important point about like and unlike fractions is we can add and subtract. We can only add and subtract the like fractions, not unlike fractions. Although we do add and subtract unlike fractions, but by converting them into like fractions first. We'll talk about this in the classes because it's a longer topic to discuss. So for now, this is it. If you have any questions regarding what we have discussed today, please let me know.
No unit fraction?
Sorry,
No unit fraction?
we are not going to discuss it today. For today, this is the only thing that we are going to discuss. I hope what we discussed today was clear. We are not completing the whole chapter today, Bhargav.
Yes, as it is of the demo, so it's just like how the main classes will be. Okay, so that's why sir has taught two topics. So I hope you both have enjoyed the class. Welcome, Kalturi Lasya. So hope you enjoyed the demo as we have met after that, right? So you have joined the class beforehand also. This will be the first time that you are joining a girl. Kalturi, you are joining for the very first time, or you joined her before also? You have joined. Okay. So all right. So with this, we'll be going to take a leave and we'll join you in the main classes. Okay. If you have not enrolled yet, quickly enroll it. Okay. Bye bye. Take care.
Bye, ma'am.
Hello. Hello, Asya.
Daddy.
Okay. Madam, hello. Hello.
Hello.
Yes, sir. We can
Uh,
hear you.
yeah, madam, so I'm in office. I don't have an option to just join from my side. So, Lasya is going to take a class. Mostly the Vikram sir will take a session further, right?
Yes. From sir will be going to take sessions.
Okay, no issues. Thank you.
All right. So
As-
welcome. I have posted
Actually,
the
I'm
links.
planning to
So
join
this
at
will be useful
6:30,
for
but
you.
I am stuck with office meetings. That is the reason I don't have time to join.
No problem. So we can understand. Any queries you have, I have sent you the contact number also. So you can call us on support numbers, right? So we'll be happy to answer your each and every. Okay.
Sure, sure.
Okay. All right. Bye bye. Take care. Happy
Bye, sir.
day.
Bye.
You can
Bye,
paste these
everybody.
links with you. Okay. Bye bye.